In today's video, we're going to explore the language of equations. So let's begin. So there are numerous ways that I can explain equations by using words. But let's say I explain an equation using words. How do we then write that equation out algebraically? We've got 2 is added to a number, then is divided by 4 to give a solution of 12. Let's go step by step here. The first part is 2 is added to a number. So we've got our number S and we're adding 2 to it. After we've done this, we're going to divide by 4. Now it's very important that we must tell the person here that we're doing S plus 2 first. To do that, we can put brackets around this statement. BEDMAS says that we must do brackets first. Then we divide by 4. The final part of the statement is to give a solution of 12. That's the same as saying that this is going to equal 12. So this is equal to 12. Now we can actually rewrite this statement in a bit of a different way. Mathematically, when we're using division, we actually usually represent this as a fraction line. So we can say that this is going to be divided by 12 like this. Then we put the S plus 2 on the top here. But we don't need to include our brackets here because when we represent fractions, there are actually invisible brackets that exist for our numerator and our denominator. And of course, this is equal to 12. Now what's in blue here and what's in green do actually represent the same thing. But the conventions that we use in mathematics say that we write division as more the fractions. So what is green is more conventionally appropriate. But we'll talk about that more in a moment. Let's have a look at question 2. That's saying 6 is added to 7 times a number, using the pronumeral C, to give a result of 20. Let's break this up to that first bit. 6 is added to 7 times a number. What that's saying is we're going to do 7 times a number first, then whatever that equals, we're going to add 6. So let's write that down. We're going to do 7 times a number, using our pronumeral C, then we're going to add 6. Now you might be thinking here, we need to put brackets around the 7 times C. Now, whilst that might make an incorrect statement, BEDMAS actually tells us that we need to do multiplication before we do addition. Now, that means we need to do the 7 times C before we add 6. So we don't need brackets here. So let's look at the rest of the statement. This gives a result of 20. Now gives a result means equals. So this here will be equal to 20. But when we actually write 7 times C, mathematical conventions say that we can write this as 7C. Then add our 6, which will equal 20. So once again, what I've got in green here is much more conventional to what we write in mathematics. Looking at question 3. The sum of 3 and a number x, remembering that sum means adding these together, is then multiplied by 5 to equal 0. So breaking that up, we're first doing the sum of 3 and a number before we're multiplying by 5. So we've got to take this 3 and add it to our number, which we're representing as the pronumeral x. But now we've got to multiply this by 5. Now if I just write multiply by 5 here, BEDMAS says that we'll do x times 5 before we'd add the 3. So what I need to include here is brackets around this addition to make sure we do the sum of 3 plus x first. Now this is equal to 0. So we write this equals 0 at the end here. Now once again, the conventions of mathematics say that we can write this a different way. We can actually write this as 5 immediately with the bracket 3 plus x. And then close your bracket. And that's equal to 0. Now when we write it like this, we've got an understanding that because the 5's immediately before the bracket, that 5 is going to multiply the answer of whatever's in the bracket there. So what's in green is how we would conventionally write this expression in mathematics. Let's look at question 4. A number that we're going to represent as t is multiplied by 5. Then 9 is added to give a result of 3. So let's break this up. First, we've got a number, t, is multiplied by 5. So we write this as t multiplied by 5. Then 9 is added. So we plus 9. Now we've got to decide here, do we need brackets? BEDMAS says we do multiplication before addition. So in this statement, we would go t times 5 before adding 9. So we're okay without brackets. To give a result of 3. To give a result is the same as saying equal to. So this is going to be equal to 3. But like before, we can actually express this a little differently. T times 5 can be expressed as 5t. Then we add our 9 and it'll equal 3. So as you can see, we can take written statements and describe that written statement in an algebraic form. But let's have a review of some of those conventions we use in maths. Now there were 3 common conventions that we came across while we were doing those written problems. And a question that you might have is, why do we even have conventions in mathematics? And I want you to think about this. When we're writing words on a page or reading words on a page, we typically read those words from left to right. Now there's no reason why we couldn't actually just write the words the other way and read those words from right to left. So why does everyone write words from left to right? Well, it's to make sure that everyone has an agreed upon way to express their writing. So what that means is anyone from anywhere, assuming they understand the language, can just pick up that piece of writing and read it perfectly fine. So why do we have conventions in mathematics? Similar sorts of reasons. So anyone from anywhere can come into that mathematics and have an agreed upon way to represent something. It doesn't mean that you couldn't represent it a different way, but it gives an agreed upon way to represent things. So what were those 3 conventions we came across? Well, the first one was multiplying. And we read statements like a number multiplied by 6, which we could write as x multiplied by 6. Now, if we have a number and a pronumeral multiplied with each other, the conventions in mathematics say that we need to represent this as the number first, which becomes what we call a coefficient, multiplied by the pronumeral. So that's how we represent multiplication. What about the dividing problems? Well, when we came across a statement that said a number divided by 3, we could write this as a number, x, divided by 3. But the conventions in mathematics say we don't actually use this division symbol. We represent this in fractional form. So conventionally in mathematics, we represent this as our pronumeral divided by using a fraction sign and then whatever we're dividing by. And the third convention we came across was when we need to add brackets to a problem. And we also came across a situation where we need to do the brackets first and then multiply. For example, we might have had 10 subtracted from a number, then multiplied by 3. So we could write this as 10 subtracted from a number, which I'll write as x, then we multiply that by 3. Now, if we've got a statement in brackets like we've got here, and we're going to multiply by something, the conventions of mathematics say that we represent this with whatever we're multiplying first, and we don't need to include the multiplication symbol. We simply put the statement in brackets like I've put here. Okay, so now it's your turn. Question 1 here, I've got some written problems here that I'd like for you to have a go at representing in algebraic form. Try to represent them using the conventions of mathematics. Now in question 2, I've actually done the opposite. I've given you the algebraic statement. Can you write a written representation of that statement?